All right, guys. Here we are again. We in a different training than we're all accustomed to, but hope everything's going good at work and at home too. Everybody keeping safe and well and taking care of task at hand and just trying to make it through. I hope May will bring a different outlook on this country and this world as far as this coronavirus goes. Hope everybody's keeping up with the lessons and keep sending them in to me so we'll stay caught up. I'm grading them, and I'll send you some feedback on the questions on each chapter, and I'll go over some of them and maybe even review them. But this week is going to be the lesson for April the 9th, and it's going to be on fixed electric space heating equipment, Article 424. It will have, let's see how many questions, about 13 questions in the back. It's not a long chapter, but I think all of us have been involved in some heating equipment. It's good to know. It's good to be able to go to the code book, look it up, answer the questions, send them in to me. If you have any questions, holler at me. Again, I haven't heard anything as far as the date we'll come back, and I imagine y'all be notified. There is a email that come out about registering. I'm sure all of you got that. I'm not sure on the procedure of registering for the school. If you all got that email, then comply with whatever they want you to do and take care of that. If you have any problems, holler at me and I can get some questions answered if you have them. But I'm not sure exactly. This is my first year for this. And so right now I'm going to start the video with Mike Hope. And y'all just hang in there with me. Keep doing what you're doing. And feed me your questions and answers. And let's keep this going. And if you've got any other suggestions at this time, this is kind of working for me if it is for y'all. And then we'll get caught up and go back when we are able to meet. And especially on motor controls and writing ladder logic, but that's going to be coming up next week. So I'm going to start this video, and then we will see what's next, and I appreciate it. Here we go.
Okay, I'm done with appliances. Electric space heating equipment. The scope is the space heating. What do you guys up north call these things?
Space heaters.
No, they call them something. I thought they called them like furnaces.
Furnace. Yeah, furnace.
Yeah, so different parts of the country call them furnace. It's electric space heating equipment. Now, okay, we'll just hold up right there. Branch circuit requirements. Now, what it says is, in 424.3b, is that electric space heating equipment is considered a continuous load. Well, then you have to go back to 210.19. It used to say that the conductors, Brian, let's make a requirement here. It used to say that the branch circuit conductors for electric space equipment shall be sized no less than 125% of both the heating and the motor load. You guys remember that?
Yeah.
They pull that out and they just simply say this. Look at this. And I do not like this. Now what do you got to do? Now you got to know what a continuous load is. Then you got to find how do you size branch circuit conductor continuous loads. Now you got to go to 210.19A1. You got to size the conductor 125%. Where if we simply told people how to size the branch circuit conductors right here and not tell it it's a continuous load. By the way, we didn't do this, but in water heaters, they did the same thing in water heaters. They said a water heater at 120 gallons or more is considered a continuous load. Now you got to take that and go back and go around a circle. Rather than simply say, shall be sized no less than 125% of the continuous load.
120 gallons or less, wasn't it?
Yes, I know what I said, but that's right, 120 gallons or less. Yes.
I just want to maybe make a suggestion for a future graphic. Instead of showing a furnace, I'm thinking like baseboard heat would probably be a better example of something that would actually be a continuous load. So this is going to cycle off and on. The baseboard heat, when it's cool, it just turns on and it never shuts off.
No. You missed the point. It says it's considered a continuous load,
Oh, I see. Even though it's not.
even though it's not.
Got it.
Sure.
And then when you get the water heaters, it says it shall be considered a continuous load,
Okay.
even though it's not.
That says shall be considered.
I know.
Okay.
That's what I'm saying. But I mean, it's
I
not
don't
a
know
continuous
why they're getting
load.
hung up on that. I mean,
You understand?
you just figure the
Yeah.
load
A heater
for its
is not
maximum
a
load
continuous load.
and let it
Right?
do
It
its
turns
thing.
on, it
when
turns
it
off,
needs
it turns on, it turns off, it turns on, it
Right.
turns off. However, 424 3B says it shall be considered a continuous load. They use the same language for water heaters. So if you consider it a continuous load, then you have to size it as if it were a continuous
Right.
load.
I always size that
Then we
way.
take the 125%.
Every load
Makes
that I
sense.
We're right
run
back to
upon,
where
whether
we've
it's
always
running
been.
or
We haven't moved anywhere.
halfway or what, the maximum load.
I see that they just
What I do.
reduced the verbiage in the code.
Yeah, but it
because
makes it
it's
harder
always,
now.
always been like that.
No, what it used
Well,
to say was this. Here's what it said. Branch circuit conductors for electric space heating equipment shall be sized at 125% of both the heater and the motor load. We never talked about whether it was continuous or not. We just simply say that's how you size it.
Right.
And we don't really care whether it's continuous or not continuous. We just simply say that's how you're going to size it. Now it says it's a continuous load, even though it's not, but it's considered. Now we got to go to 125%. Anyhow, I think the language of telling somebody 125 here is better than just simply giving a philosophical description of the type of load it is. Eric.
Yeah, so if you put the 125% requirement right here, then that means that you would have to use 125% conductor even if you have a 100% rated breaker.
That is 100% correct, where if you had a 100% continuous loaded breaker, you could have sized it at 100% continuously, but they don't make 100% continuous rated breakers that you'd ever put on electric space heating equipment. Not electric space heating equipment, because they start like at 400 amps. But probably somebody made the argument that did not know the range of overcurrent
Right.
continuous load, and they said you really shouldn't say 125 because you had the provision to be able to use 100% continuously. So we'll make a public input to try to make it clear. I mean, just to make it back the way it was.
Right.
Here's another thing. If you've been I've been doing code now for 41 years. I'm probably going to do maybe another 10 or something more years later on. And I see this happen to my wife. She'll say, "Oh, I wore that blouse." The girls are buying clothes. "Oh, I wore those shorts. Oh, I did that. I did that thing. What happened?" It goes all the way around. Now, what happens is, but I see this all the time. We had a rule, and then 20 years or 30 years later, guess what? It changes, and then 20 or 30 years later, guess what? It comes back at another time. So we'll see that. All right, we're moving on. Anybody have any comments? Okay, it's considered a continuous load. Mike, the text needs to say shall be considered a continuous load, not that it is a continuous load. Thus, you'd have to size the branch circuit conductors, and we need to make a reference to the rule here on 210.19 on this graphic. So let's work an example. Well, we have 9-point kW heat strip. That's assuming 240 volts. I guess we should change that rating. Actually, on this appliance, should be 230 volts, right? Because equipment is rated not nominal. It's rated 9.6 kW. I'd have to look at the label. I can't imagine that it's rated 240 volts. All right, 9 kW. Let's work what we have, though. Leave it for right now. 9.6 divided by 240 comes out to be 40 amps. You add the motor load, it gives you 43. You take 1.25, comes out to be 55 amps. We have to use the 60-degree C terminals. We go to the code book on table 31015B16, and we find out it's a 6-gauge wire. And if you went to branch circuit rules, the branch circuit rules in 210.20 says that you'd have to size the overcurrent device the same way. So no less than a 54 amp overcurrent device, no less than 54. So therefore I'd have to have a 60 amp breaker. I have to make sure the wire is protected at its ampacity. So I have a 60 amp breaker, a 50 amp wire, 55 amp wire. Is that okay?
Yep.
Because we go to 240.3b says that where the ampacity of the overcurrent device, 60, where the ampacity of the conductor, 55, does not correspond to the standard size overcurrent device, then we can use the next size overcurrent device, 240.4B. So we're kind of putting in some rules together here. So I put a 60 amp breaker using Romex, let's say, if I were using Romex, 6-gauge wire or pipe. It doesn't matter which one it's going to be. And Romex, by the way, is 60 degrees C. Anyhow, even if your terminals were rated for 75 degrees C. Disconnecting means on appliances. I like this. Disconnect must be within sight from the motor controller, and the heater. And we probably should have done it to the appliances. Separate these things where it's within sight and not within sight. Makes it easier to see the rules. So that's easy, within sight. Okay, where the disconnect is not within sight of the controller and heater, the disconnect must be capably and locked in the open position. Brian, let's make a public input that where the disconnect is not within sight, then at the appliance, there's some notification, right? And complying with 110.21B, permanent, where the disconnect would be located at. Unit switch. Now, this one will work. This one says a unit switch with a marked off position that's part of a fixed electric heater can serve as a disconnecting means. So I guess you can order air handlers with the disconnect built in.
Yep.
If that's the case, then you just run the wires directly to it. Now, however, the rule says that overcurrent devices, was at 240.24a, says overcurrent devices have to be what? Readily accessible.
Most of
Readily
your
accessible
commercial
You can't use a tool to get to it.
units are
So therefore,
made
this
with a
cover
disconnect on them, but I
has to
don't know
make
about
sure that there's
residential.
no screwdriver
You may
required
have to
or a
take
tool
care of
to
that
open
on your
cover.
own
Brian.
residential.
Just to be clear, there's a lot of times that is not an overcurrent device.
Oh, I'm sorry.
Just a disconnect
Okay,
device.
let's try this again.
Just safety.
This is a switch,
Correct.
okay? This is a circuit breaker being used as a switch. You can put a 100 amp breaker on there, right? It doesn't matter what rated overcurrent device you have on here because this is a switch. So let me repeat what I just said and let's see if I
it's a
say
NARB
it differently.
Sometimes.
I'm sorry?
Some
a lot
of them are
of times it's a NARB,
non-fusible.
And it could be a
non-amperage rated
non-automatic,
Disconnect.
Non-amperage rated breaker.
a non-amperage rated breaker.
Yes.
So, Mike, make
Just a
sure we put
knife
the ratings
switch.
off because you threw me off by having some current marking on this.
They
and it
just
could
want
have
you to
been
be
just
able to
a
turn it off
switch.
and lock it out.
Okay, so a
Work it.
non-rated circuit breaker or a switch, a unit switch with a marked off position that's part of the fixed electric can serve as the overcurrent device. Now, let's think about this. If this is a switch, are there any rules that switches shall be readily accessible? So I should not have used the 240.24 because this would be a supplementary overcurrent protection device. And we didn't talk about that, but 240.10 says supplementary overcurrent devices are not required to be readily accessible. Right. So I'm not going to use the 240 rules. But is there any rule in the code that says switches shall be readily accessible? And we had the discussion that we didn't like the idea about the 6 foot 7 inches and all that other stuff because we felt the rules on switching and the access to them should be at the location where a switch should be considered. And that would have been switches, would have been 404, I think it's .7. And let's see, is there any requirements on 404 I think it was 404.7. 404.7. Location of switches, maybe. Indicating, that was the indicating was 7, but we should be real close to that. 8. That's what it is. So this is a 404.8 rule on the location of switches where I'd like to locate those where they belong. All switches and circuit breakers used as switches, which is what we're doing here, shall be located so that they can be operated from a readily accessible place. Oh, hold on. Let's think this out. So a switch has to be located from a readily accessible place. Let me keep reading, though. They shall be installed such that the center... Okay, Eric. Is this saying I could use a screwdriver?
Well, to me, that means that when you walk up to it, the equipment has to be in a readily accessible place.
Right.
The switch doesn't have to be readily accessible.
Nope.
Not at all.
I can have a screw.
The place has to be readily accessible.
Because let's go to supplementary overcurrent protection devices. See, if there was an overcurrent device, if there was, that's in addition to the overcurrent protection for the circuit. Is that right? Mm-hmm. So therefore, this is a supplementary. Let's go to 240.10. I believe that's the right rule. 240.10 on supplementary. I like it when we're doing this, guys, when we kind of move around rather than just saying rule. Okay.
424.19A.
Okay. Where supplementary overcurrent protection is used for luminaires, appliances, other equipment, or for internal circuits and components of equipment, it shall not be used as a substitute for the required branch circuit overcurrent device or in place of the required branch circuit overcurrent. Supplementary overcurrent device shall not be required to be readily accessible. So, Eric, this is a supplementary overcurrent device. This is not a branch circuit overcurrent protection device. This is not required to comply with overcurrent readily accessibility. However, we read the rule on switches that switches said that the switches have to be located at a readily accessible place. Okay, David, were you going to add any feedback?
No.
So I will take back what I said. This switch could be in a cover, and you could require a screw. Now let's think about this. Who is going to be having access to that disconnect, and why would they have access to that disconnect?
Service tech.
Right. This is for the service tech to be able to work on the equipment. They take a screwdriver, let's say if they wanted, if that's how they did it, they would open it up. That's different than a service disconnecting means to a building, because the service disconnecting means switch is required to be readily accessible. Brian.
And practically speaking, most of these that I've seen, it does not require a tool, but we have seen some where you have to pull the first cover off to be able to shut it off. So
you know what it could be is, it could be behind this cover.
right.
Right? Dave, you follow what I'm saying?
Yeah,
No, it's
but
not have the door here, but you
usually
take
they-
off the screw here, and then there's your breaker, and then you turn it off, and they can work on it.
Usually they put the door on there or the breakers.
But I want us to understand code. I would have thought it had to be readily accessible. Now I know it has to be at a readily accessible place. And I would have thought it was an overcurrent device. It had to be readily accessible. It's not. It's a switch. Okay. A lot of new stuff there. Disconnect for duct heaters and controllers. The disconnect for a duct heater must be accessible and be installed at or within a controller. 1 second. This is, wait a minute. The disconnect for duct heater must be accessible and be installed at or within sight from the controller. So within sight. Okay, so the duct heater has some kind of controllers, and controllers making break contact. So this is the disconnect. Is there any rule that if it's not within sight, it has to be capably locked in the open position? If you're wondering why this little duck is up here, is because Mike had this word D-U-C-K,
Yep.
and all of us sent in edits to correct duck heater. And then before you know it, he kind of fixed us. He put a duck on top of it there. Let's go to 424. Is there ability it not be within sight?
Well, the disconnect has got to be within sight of the duck.
There you go. 424.65. Okay. 424.65. What does that say?
Just says accessible at or within sight from the controller or as permitted by 424.19A.
Hold on. Let's go back up here. What does 424.19A say? Right?
Yep, so it can be locked remotely.
So it could be within sight. So Brian, make sure that when you go into the text of the UNEC, that this is talking about within sight from the controller. So we need to have two graphics here, right? One showing within sight of the controller, and then another one with the reference of 424.19A, that if it's not within sight of the controller, then it must be capable in locked position. So one would be this disconnect up here, is that right? The other would be what? Put no disconnect up there at all and have the breaker down here capably and locked in the open position. And my recommendation would be that up here we have some kind of marking, not required by the code, and I wouldn't require that because we already got that in 19, is that where it's not within sight of the controller and it's capably and locked in the open position, then I would suggest somebody put a notification, hey, this is coming out at panel number, this is circuit number, whatever. Okay, guys?
Yep.
I struggle with this 424 rule, but I really worked with the graphics to get it where I want it to be, and I'm real comfortable where it's going. Article 430, motor circuits and controllers. Article 430, the scope. There's overload protection, we call them heaters. You have branch circuit, short circuit protection. You have branch circuit conductors. We have feeder conductors, and we have feeder protection. And this is a lot of what we're going to be covering in this particular part of the program. The definitions of 430.2 is what is a controller? A switch or device that's used to start and stop a motor by making and breaking the motor circuit contacts. So all of these be ways to turn on and off a motor. And this is an example of devices that are not considered controllers. These devices often control the coil of a motor starter, but they usually don't carry all the current of motor branch circuit. Let's see, the only one that could be, now this right here, no, this would be a controller. Well, it all depends on whether it's a little 20 amp circuit, right? Breaking the
Right.
circuit for a little sump pump.
Same thing with the pressure switch. The pressure switch could be the same way.
They could, okay, a little well, right?
Yes.
It's a contactor. You know, so you have whatever's making and breaking the contacts, not push buttons. Now, if these are just limit switches and this is just making contacts to a control circuit, well, then the control circuit, it's direct power that's controlling it that matters. Motor nameplate versus FLC. This is not a motor class here. We have an entire video that deals with all kinds of motor conductor sizing and calculations.
Go ahead and get into
and we'll
that.
be covering that at another time.
Article
Actually,
430.
It'll be in
There's
next
a
month.
lot to
We'll be
that.
covering that. So I'm quickly going over motor calculations. This is something that you
We'll
know you
just
really need to get the
watch on this a
calculations
little
video to
while.
really understand all the calculations in motors. So let's go through it really fast. Ready for this? Motors have a nameplate and they have a nameplate rating. And then you have the national
Important
code
information
that lists
right
the
here.
different currents of a motor. For the purposes of this program today, we will never be using the nameplate rating of the motor. We will always be using the motor code requirements because we're going to be using that to size the short circuit and ground fault protection, and we're going to be using that to size conductors. The nameplate is used to size overload, and we're not covering overload in this particular class. We cover that in our calculations class. Here's an example of a nameplate. The nameplate is calculated out with a function of this formula, having to know voltage, efficiency, and power factor, and we will never be using the nameplate for sizing the conductors and the protection device for short circuit and ground fault protection. Single motor. How do you size the wire to a single motor? Well, the code says take the conductors for a single motor are sized no less than 125% of the table full load current, not the nameplate value. And you go to the different tables and you look them up, and the table will give you a value. Let's go to a 1
I didn't
horsepower
realize
motor.
that.
So let's go to the code
You
book,
had
and
to
that's
go
going to
to
be
code book.
430.248. And there's going to be a table there. This is 48 is single phase, and 250 is three phase. So using our example of single phase, 1 horsepower, 115. I like using the voltages that are going to be nameplate rather than nominal system voltages. 1 horsepower, 115 comes out to be 16 amps. And the rule was you size the conductor no less than 125% of the table current. The table current is 16 amperes. So then you take 125% of that. It comes out to be 20 ampere wire. And then you go to the code book, and we find out that 12 gauge wire at 60 degrees C is rated 20 amperes. So let's go to the code book. Let's go home. Let's go to 310.16, which is 310.15b16. I go to the 60 degrees C column, which is the very first column here. I need a wire rated 20 amperes, and that would be 12 gauge wire. But Mike, I thought you couldn't put, well, that's it. Let's stop right there. 20 amp. No, that worked out fine, right? Right, no conflict there. 20 amp wire. Now, if you have several motors, and you're trying to size the wire for several motors,
See, if
Let's
I
say
was
one
going to
motor
do
is
that,
22
I would
amps,
jump up to
one motor is
size
42 amps.
10 wire.
the code says the
Because
feeder
I don't
conductor,
wanna
which is
load
the
the
conductor
wire
for
up
several motors,
at its maximum.
must be sized
I
not
wanna
less
have
than
some wiggle room.
125% of the largest, which would be
So I would go to
42,
size 10. Now I
times
may put it
1.25,
on a 20 amp
plus the sum
breaker.
of the other motors on the same phase. Well, then there's
But I'd
one
let
other
my
one,
breaker
which is
work before my
22.
wire would get hot.
And if I do the calculation, I would take the 42 times 1.25 plus the 22. Oh, this example is showing what happened here. Oh, it is two
I
examples.
don't want to
Okay,
load
two
a circuit 80%, which that's
42
what it
times
is, 16
1.25
amps.
plus 22
Anyway.
plus 22 comes out to be 96. I'm going to round this off. However, Mike, let's start rounding this off. We'll start making this 97 in our textbook. We start rounding it off. 97. Have to find a wire that's rated 100 amps at, ooh. You're right. Which size the wire at 75 degrees C terminals. So 31016, go to the code book, look it up, go to the 75 degrees C terminal.
Number 3.
I'm sorry?
Number 3.
Okay, without me having to go through it and find it again, it is a 3-gauge wire at 75 degrees C. And that's how you size it. Again, I'm moving really, really fast. This is an introduction. If you're not familiar with this, this is not to take you into all the calculations as it comes to motors.
No, you
Just
need to
kinda
know
give
the
you a feel.
calculations.
All right, let's move on. Let's go on to the short circuit and ground fault
All right, I'm
protection
going
of
to
a
stop
motor.
it now, and
When a motor starts,
we will
it starts
continue
at
on
high.
next week. But if you would do the questions and fixed electric space heating equipment, Article 424, send me pictures of them. If you have any questions, let me know. Like I say, work safe. And I look forward to the motor controls, especially. I've always enjoyed motor controls and learning more about it. I think it'll help you look at it as far as a engineering side of it and working out in the field. It'll help you to understand why and why they do and the protection and where they put it and what all's in the circuit to take care of the motor protection and equipment and what all's in the circuit for safety. All right. I'll see you on the next lesson. Bye.